Okay, welcome back to part 2 of the virtual lab on specific heat. Now we're doing the second part that's worth 20 points. What you're going to do, now I say we're going to start on that. Actually, you need to make sure that you answer this question over here. Compare the values of the heat exchanged by the water and the metal in the upper part. Within experimental error, was the law of conservation of energy obeyed? So you'll have to think about that and decide and explain why that was true or false. Now, let's move on to this part. What I'm going to do is I'm going to do metal Y, and y'all will do metal X. So I'm going to pick metal Y here and run this. Let's see, I'm going to set the mass to be, I'm going to do the maximum mass, 120 degrees, and let's just do the maximum, 120 degrees and 220 degrees C for this metal with an unknown specific heat. Notice the specific heat we don't know. And leave the water at 30 degrees and 20 degrees. So hit start, and as you notice, the calorimeter lowers the thermometer into the water. The unknown specific heat metal Y, and off it goes. Notice how the temperature continues to go up because we had a really high temperature here, so it goes up and up and up and up, and eventually it stops. Aha! It goes constant, so we're going to have to pick the right number here. So it varies from 82.97, I thought, 7, all the way down to 82.93. So we'll look at the middle of that, and let's get this going again. Now the number in between 82.97 and 82.93 is 82.95. Now it stopped moving because that's the way this recorder goes. So I'm going to put this number right down here. Right there. For the temperature final of both, which is going to be 82.95. And that's degrees C. And I'll go ahead and record the rest of the information here. 120 degrees is going to go, 120 grams is going to go right here. That's the mass of the metal, 120 grams. And the temperature right there is going to go right here, 220 degrees C. The mass of the water down here, 30 grams. Gracious, 30 grams. And the temperature of the water, 20 degrees C. It's going to go right there. 20 degrees C. Now if we're going too fast, just pause it. You'll be good. Then oh yeah, the specific heat of the water, that comes from right here. That's the same as it was last time, 4.18 joules per gram degree C. There we go. So now we have all the data, and we have our equation right here of Q is equal to mc delta T. And what we're going to find, the heat Q into the water. So we're going to be looking at all the information for the water. So that'll be below this line right here. So let's put it all in. Change colors. So Q is equal to the mass of the water, which is 30 grams, times C for the water, 4.18 joules per gram degree C, times my delta T. Dadgummit, I didn't calculate my delta T. Because remember, that's going to be the final minus the initial, right? Final minus initial. So the final is 82.95. 82.95 minus my initial, which was 20 degrees. So we have the temperature, the delta T, 65.59, which ends up being a Q of 84 8224.9 joules, and again we're limited by this 4.18, 3 significant digits, so that would give me the 3 significant digits would be 8, 2, and 2. This 4 does not change anything, so that would be 8,220. The 0 will be our last digit, insignificant as it is. So that would be the number of joules, or the heat that is transferred into the water. Now here's the idea for this step 2. It says since the heat from the metal is the same as the heat into the water, right? That's what we found, is the heat that came into the water was the same as the heat that came out of the metal. So there's the same amount of heat. The only difference is the sign. So Q for the metal would be negative 8,220 joules. So what we want to do is we want to take this equation here, our Q is equal to mc delta T, and find the specific heat. That's what they're asking us for. Find the specific heat of the metal. So let's write that Q is equal to mc delta T. We want to solve it for C, so we can find the specific heat of the metal. So if I want to get C by itself, I've got to divide by m and delta T. So there's m and delta T. If I do that on one side, I must do it on the other side. So m delta T. They're going to cancel out over there. M on the top, M on the bottom, delta T on the top, delta T on the bottom. So we end up with C by itself. So let's rewrite that as Q divided by M delta T, and that's going to be equal to my heat capacity, C. That's what I'm looking for. So, again, I'm going to take negative 8220 divided by the mass of the metal. That's going to be up here. Mass of the metal, 120 grams. And divided again by the delta T, which I have to go over here and calculate. Delta T is equal to the final temperature minus the initial temperature. Okay, and in this case the final is 82.95 minus my initial, which was 220 degrees C. If you notice, that's going to be a negative number. So that comes out to negative 137. So I'm going to put that right down here. Times, put that parentheses, negative 137 degrees C. Alright, so do all that calculating to find out what C is, and I'll come back to you in just an instant. So there we are. 0.4998. We've got to round it to 3 significant digits. The 8 is going to change the 9 to a 10. That's going to change that 9. So it'll change everything. So it'll be 0.500. And the units would be joules per gram degree C. All right. So there's an example of how you do everything. Now you need to come back and do, I'm sorry. That number is not right. That number is not right. Okay. Let's try that again. That number is 0.4797. We need to get it to 3 significant digits, which would be 0.480. I'm sorry, what am I saying? Let's try that again. We've got 3 significant digits, so that 7 is going to make this into a 0, which is going to increase that. So I'm saying it right, 4.480. That's going to be joules per gram degree C. So hopefully that's the numbers you're getting from all of this calculation here, instead of my erroneous ones before. There you go. Be sure that you answer all the questions and show all of your calculations. Y'all have a